Hello, good morning. I'm Michelle Lochner presenting on the production of methanol from natural gas. Moving on to the chemical methanol and its uses. Methanol is the simplest organic alcohol with the chemical formula CH3OH. It is highly poisonous when ingested, but it has a variety of important uses. Some of the important uses are: it serves as the base chemical for the production of plastics, resins, acetic acid, and more. It has also helped increase the synthetic materials revolution, that is foams, glues, and textiles we now use daily. Another important use is it's a source of clean fuel which is now used in the hydrogen fuel cells as a hydrogen carrier. It's used in our everyday chemicals such as windshield washer fluid, varnishes, and many others. Lastly, it is currently being researched upon as means of storing renewable energy, decarbonize the shipping industry, and create a carbon neutral fuel cycle. On the process flow diagram for the production of methanol from natural gas, we have two raw materials, that is the steam and natural gas, entering a reactor, and it gives out two products, that is a methanol coming out as a main product from an outlet and another byproduct, that is the water coming out from another outlet. Moving on to the process description, we have desulfurization that removes sulfur compounds to protect the catalyst. Steam reforming, it converts the methane gas to syngas that gives us carbon monoxide and hydrogen gas. Another is the gas compression that pressurizes syngas for methanol synthesis. Methanol separation and purification, it cools to condense crude methanol and distills to remove water and other byproducts. Another is the storage and transport. The pure methanol is then stored in tanks and shipped for fuel, chemical or energy research applications.
Okay, so now we are moving to the important units of the plant. Every chemical processing plant requires a number of units for smooth running and optimization of products. The unit requirements of our plant includes the core process unit, which is we have the feed gas treatment unit. Here, it removes sulfur and other contaminants from the natural gas. We then have the steam reforming unit. Here, it converts natural gas into syngas, which is basically composed of carbon monoxide and hydrogen gas, using steam and catalyst. We then move to the methanol synthesis unit, which converts syngas into methanol over a catalyst at high temperature and pressure. The methanol then moves to the methanol purification unit, where distillation columns are used to separate the methanol from water and light ends. We then have the transport unit, which is used to convey the methanol to other areas of interest. Okay, so now we're moving to the utility and the support system. Here we have the boiler and steam generation system. It provides steam and heat, which is required for the whole process of the reactor. Then we have the cooling water system, which is used to remove heat from the various units to prevent breakdown of the whole reactor. We also have the air compression unit, which supplies air to the basic instruments and the whole plant in general. We also have the nitrogen generation unit, which is used for inerting and purging, that is the methanol being produced. You have the power supply unit, which is used to generate or supply electricity for the basic operations of the company. You have the water treatment plant, which ensures quality of water which is being supplied to the reactor and also the basic process needs. You also have the fuel gas system, which is used to supply fuel for reformers, heating, and the reactors in general. We then move to the flare system, which safely burns off excess gases. And then we have the tank farm for storing methanol, water, and other raw materials. We are now moving to the other important unit of the plant, which is the administration and operation units. Here we have the control room, which monitors and controls all the plant operations in real time. We also have the administration building. This is where we have the offices for the plant management, human resource, accounting, and etc. We also have the maintenance workshop, where we have tools and equipment for mechanical, electrical, and instrumentation repair. That is the general maintenance of the whole company. We then move to the laboratory, which is used to test the quality of products and raw materials in order to ensure optimization of products being produced. We then have the warehouse or the stores, where spare parts, chemicals, safety gear, general inventory, and also raw materials are being kept for use. We have the safety and fire station, which is more concerned with emergency response and fire protection. You have the canteen and welfare facilities. This is where staff and general workers of the company can go for dining, changing, rest areas, and even first aid. More importantly, we have the security gatehouse, which is used to monitor entries and exits of the company as a whole. So now we are moving to the computer needs and inputs required for our company. First, we are looking at the process monitoring and automation system. Here, the system required is the distributed control system. This has input devices such as thermocouples, level sensors, flow meters, pressure sensors, and gas analyzers. This helps to measure process temperatures accurately, to detect fluid levels, and prevent overflow of dry run conditions. They also help to monitor gas and liquid pressures for safety, efficiency, and control loop stability. We also have the laboratory and quality control systems, which require the laboratory information management system to function. The basic input devices are barcode scanners and analytical instruments such as GC, FTIR, titrated, titrators, etc. Here we are able to track and manage methanol and raw material samples, link physics samples to digital records and LMS. They are needed basically to ensure sample traceability and record accuracy. We now have the maintenance and inventory management, and the system required is CMMS, also known as Computer Maintenance Management System. Here, the devices required are barcode scanners and also mobile tablets with cameras. This helps to log incoming and outgoing parts, track usage, and reorder stock automatically. Also for scanning barcodes, taking photos, and updating maintenance records live. We also have the networking and data infrastructure, which require the IT or OT network infrastructure to function. So here we have devices such as environmental sensors, which are able to sense humidity and temperature, and also network activity logs such as LAN or WAN. They basically protect IT hardware from environmental damage, and also they monitor data traffic, detect intrusions, and secure operations. So now we are moving to the software needs of the company. So for process simulation and design, software such as Aspen HYSYS, ChemCAD, and DWSIM are required. These are basically used to simulate natural gas reforming, syngas generation, methanol synthesis, and distillation columns. Also, they are also serve as open source simulators for thermodynamic modeling and basic process design. For the plant and piping design, we have softwares like AutoCAD Plant 3D, Aviva P and ID, Smart Plant P and ID. These basically help to create 3D plant layouts, piping networks, and P and ID diagrams. They also generate intelligent piping diagrams linked to equipment databases. For the mechanical design and stress analysis, we have softwares like ANSYS, Caesar 2, and SolidWorks. These help to calculate the stress and defection in high designs and visualize physical equipment. They also simulate the flow of fluid, heat transfer, mechanical stress in reactors, compressors, etc. We also have the control systems and automation. Here we require softwares like MATLAB, Python, Honeywell, Experion, PKS. These help to simulate dynamic control systems. Also, they are able to script custom logic, machine learning for control or optimization, and data logging. For the safety analysis and risk management, we have software like PHAWorks, Silver, Levels, SIL. Here they are able to calculate and verify safety integrity. They are also used for safety instrumented systems and then also for hazard and operability analysis and risk assessment sessions. For the enterprise management and maintenance, we have a software like IBM Maximo, which helps to plan preventive maintenance, tracks work orders, and manages spare parts. Now we are moving to the network connectivity of the plant. And for our plant, we have suggested that the wired network connectivity is best for optimum productivity. So a wired network connection is ideal for methanol production plants because one, it is super reliable. Unlike the wireless network connectivity, wired connections don't easily get disrupted by metal structures or noise from machinery. Also, it is fast in that it is perfect at handling all the real-time data from sensors, control systems without delay. It is secure, meaning that it is harder to hack as compared to wireless network since physical access is required for usage. And also it is better for critical operations. Things like emergency shutdown and automated controls need instant response with no room for lagging. And finally, it lasts longer. Once it is set up, it rarely gives trouble and doesn't require much maintenance. This brings us to the end of our representation. Thank you very much for your audience.